Hello, good day everyone. My name is Abdurrahman Umsent from Wentech, and today I'm going to be explaining the humid air turbine cycle. First, I will just go through a quick overview, how it's been discovered, and then its main components, advantages and disadvantages as well. So about the function, it's been discovered in the late 80s by Fleur Daniel, who patented his new gas turbine system, which is called HAT, humid air cycle. It's this humid air turbine cycle. It's an intercooled gas turbine cycle having both air and water mixed together in an evaporator before entering the combustion chamber, and a recovering system for exhaust gases, which absorbs heat from the gas coming from the outlet. Then the system efficiency, it can be improved by 50 to 60%, and it consists of 7 main components. We've got the compressor in the first stage, intercooler and the aftercooler. We've got actually 2 compressors, and then the saturator or the evaporator, recuperator, which is a gas-gas heat exchanger, economizer, which is a water-to-gas heat exchanger, and finally the combustion chamber, which has 2 inlets, the fuel plus the air coming from the evaporator. And now we're gonna look at the cycle diagram and the temperature versus entropy diagram. So as you can see, we've got 3 types of lines. We've got the black line, which is air, blue line, which is water, and the red line is the exhaust gas coming from the final stage. So 3 inlets that occurs in this diagram, which is air, water, and the fuel. And the outlet is gonna be the excess water, exhaust gas, and the work from the turbine. So the first stage is air that is coming into the first compressor, which compresses the air, and then because it's being compressed, its temperature is gonna rise, which needs to be cooled down for a better system. And then it goes into the first intercooler, which is a water to gas heat exchanger. As you can see, there is a water inlet as well. So to take some heat from this air, it just exchange the heat before getting into the saturator. This way we're gonna have less energy consumption. Then it goes into the second compressor, which generates heat again, and the same things happen, which is the aftercooler. The water absorbs some heat from the air and then gets into the saturator again. After that, the air just goes into the turbine to generate some power. But this is not just the only source of power generation. There is as well a mixture between fuel and air. Therefore, the air goes into the saturator, where water is coming from the first intercooler, aftercooler, as well as the economizer, which is a water to air heat exchanger, which absorbs heat from the exhaust gas and get it into the water to get a bit warmer before being injected into the saturator. After that, the excess water will just be dumped away, and the air it goes into the recuperator. So and to get most of the energy coming from the exhaust gas, the recuperator, which is a gas to gas heat exchanger, the gas coming from the saturator or evaporator, it absorbs heat from the gas exhaust and then goes into the combustion chamber, where it meets with the fuel and then drops the steam. It's like producing some sort of stroke, which turns the turbine, and then it produces the power. For the water flow, it's gonna be between 0.2 to 0.5 kgs per second, and the fuel used in the combustion chamber is gonna be methane with a heat value of 43.12 megajoule per kgs. So for the air coming in the first place, it's gonna come at a normal temperature, which is about 288 Kelvin, which is 15 Celsius, and it's gonna be at atmospheric pressure. Anyway, and at the end, the pressure loss at the combustion chamber is gonna be 3%, and the final maximum temperature is gonna be 1273 Kelvins. Now looking at the advantages and disadvantages of the system. So the advantages is that it increases the system efficiency by 12 to 20% if it's been installed into a new turbine, as well as it increases in power output. It reduces the nitrogen oxides or greenhouse gas emissions in general. Also, it decreases a decrease in compression work and a higher turbine work. So the disadvantages, we've got the higher water flow, extra maintenance costs, and more energy losses during heat exchanging. I hope you guys enjoyed the presentation and you've got more information. And thank you so much. If you have any questions, I'm here. Thank you.